My client brings in a second Bryston because the other one with both lights blinking, he was convinced that that's not right. He has one now that has one light blinking and the other one solid, and he feels that they both should be solid. So we're going to look at this one and see if we can see why one's flashing and the other's not.
So I'm back on the Brystons again because the guy that owns us has two of them. And he says one of them, the light blinks when there's music playing and goes solid green when there's not. Or actually, the other amp I looked at, the lights blink when there's music playing, goes solid green when there's not. And this one, he says one stays green all the time and the other one blinks. So he feels that the ones with the blinking lights must have a problem. So this is the one that one light blinks when there's music playing and the other one does not. I figured I'd take a look at it and just see if I can spot anything that might be problematic. Check this out. So this is the shot of the board that's got the LED on it. It looks like there's a bit of burning on this board. It looks like it's been a bit hot. So I'm going to pull the board out. It's got a couple of small screws. They're going to be a real son of a bitch to get into. But I'm going to pull this board out and see whether there's anything, any connections or anything on here that are bad. Oh, this is going to be fun to get this out of here. This is ridiculous. Because the amplifier works, I have a feeling this is the board that detects if there's clipping. So I have a sneaking suspicion if there's going to be a fault, it's going to be somewhere in the sensing circuit. The one time that the teeny turner comes in handy. Getting into tight spaces like this is ridiculous. I bet you it's the amp that's staying green. I bet you that one's the one that's got the problem, the side that's staying green. And the one that blinks is what it's supposed to do. But I'll never convince this guy that because he figures that it's not supposed to flash. All the literature I have found on the amp shows that its power on is green, it blinks when it's got signal, and it turns red when there's clipping. So let's remove the board here. Well, it does look like this has been kind of... Oh, look at this. Yeah. You think maybe this is where the problem is, right here on this plug. Let's take the other one out and take a look at the other side. Got the screws out of the other side. Let's take a look at this one and see if it's in as bad a shape. Oh, this one's even in worse shape. Yeah, so maybe this is part of the problem right here. These plugs have deteriorated on the sense boards. I think what I'll do is I'll just solder these wires right on because this is shot. There's no way that that's going to be making a good connection. This whole plug is just falling apart. I don't want to have pins come off on something like this, have connections fall off on it. I'll solder those right onto the headers, and then we'll power this thing up and see whether the lights flash when it's running or whether they stay solid. But it's been hot. This has been very hot. Look at that. Oh, great. Now I'm gonna have to solder this on before I lose these pins, before the wires come off and I lose which ones they go to, because the red wire just popped off on this side. This is probably where his problem is. So let's just look at the back side of this board. I was going to solder the pins on. I figured I'd take a look at the back side. Look at this. This has had a lot of heat on this board. Holy crap. This has had a lot of power through there.
The resistors get hot like that because they're dropping the B plus and B minus main rail voltage down to 15 volts, which is regulated by two Zener diodes tied to ground. So they're dissipating a lot of current, current from that B plus and B minus. That's why they've gotten so hot and damaged the connections.
So I'm going to resolder these resistors. I'm going to put the wires right onto the board itself as opposed to through that plug. But we'll reflow these connections here that really look to be pretty sad.
So what I'm soldering, this is the ground or common point for the Zener diodes. That's the ground lead. The two Zener diodes off there, one for the positive, one for the negative, that go through those resistors. The two outside traces you see going around the edge of the board, that's the plus and the minus 15 volts to power the op amps on the circuit. Of course, the guy that owns this, he's got two more. He bought four of them. So he's going to be bringing me these other ones. And they're going to have the same problem because I went back and checked the second amp, which we're going to look at later here. The one I looked at last week that was functional. Well, it's functional, but the boards are in the process of going bad like this. So I took care of it while it's here, and I'm going to have to do the same for his others, I'm sure.
Those are the ones that are really bad. On that board, cable down here that's all, of course, a connector that's all falling apart. But I've got the pin out written down, so I know which pins go where. So it's just a matter now of just reconnecting the either soldering these onto the actual plug itself, which is one way of doing it, or putting the wires right down to the board itself, which might be a better solution, to solder the wires right down to the board on the back side here, just for long-term reliability. But these resistors, they're 2K 1 watt resistors, but obviously they've been getting pretty warm. I think they're using this in a voltage divider just to set up power for this board. See, it's on, they're on the V minus and the V plus, and then this is the input for the monitor, and then there's the ground, and then there's the LED power. I guess that's the LED return. And then the other ones are the ICs, control whether it turns red or green or flashes. I think for reliability, I'm not going to put the plug on, at least not on this one, because this one just deteriorated like you wouldn't believe. But I'll hardwire these ones right in and just get rid of these pins completely, because they're always a source of bad connections anyway. So we'll just eliminate them, and I'll just put the power wire right down to the board itself. I've got the pin out, as I say, so this is going to be, the gray one goes to the top here, that's the negative supply. So I'll just tin the end of the wire, and we'll start attaching the wires directly to the board. Right to that resistor itself.
I noticed when I was looking at the amplifier too that some of the resistors going to the outputs themselves look like they've been pretty warm. So I've gone over the ones I can get at. I think an amp like this, if you want to go over it completely, you got to pull the boards out and redo all the connections on it.
And I'll do the same for the other wires. The red wire is the other one that's come off. That goes over to the other side here. And then the order of them is it's gray, and then there's a no connection, and then a yellow, green, violet, and then red. So yellow, green, violet are the next colors. So yellow would go to there, green to there, violet to there, and red to the other one. As you can see, this plug here, it's just crumbling, you see. So we'll get rid of it. So the next wire is yellow.
These amps came out of a movie theater that was closed, and they auctioned off all the equipment. So they were probably left running 24 hours a day for however many years they were in service. And it's probably been in a very hot environment, in a stack somewhere. It's pretty evident that there's a lot of heat that's been in here just from the plastic deteriorating on those connectors.
I think this is where it caused confusion with the customer, because he had one that the lights flashed on both channels, which was the other amplifier, which I think is totally normal. And then this one here, of course, it only flashed on one side, and the other side was constant. And I think it was well, I didn't even plug this one in. I'm just taking his word for it. I figured I would open it up and take a look at it first before going any further. And of course, as soon as I got into it, I saw the hot resistors that had basically scorched the board. And that kind of give me a good idea where the problem is going to be. It's on this little circuit that monitors the performance, which does absolutely nothing other than blink some light. But the guy just bought these, so he bought a few of them. And I'm sure he's going to turn around and try to flip them. This is the guy that had the Macintosh DVD player that I tried to buy from him because he told me what he paid for it. And I offered to pay him what he paid for it plus a little more, but he wouldn't sell it to me. And then comes and brags to me about selling it for $1,300, and he made over $1,000 profit on the thing, and that's including after he paid me to fix it, and he ground me down on the price. And yet he still brings me stuff. And I'm sure there'll probably be a dispute over how much this is going to cost him too, because that's just what I have to deal with. Okay, that should get this board up and running. I'm going to do the same for this other connector over here, because this one's also falling apart on this one. It's just as bad, you see. The connections here are all burning, so we'll do the same on this one. I won't do this one on camera because you guys have already seen what I've done here on this one, but this other one will do exactly the same. Wire it in directly, and then we'll give it a try. Okay, I got both boards soldered. I'm going to install them back in the circuit first before I fire this up. And we'll put them back in, fire it up, and see that they both do the same thing. All I can say is thank God for Robertson screws, because you can put it on the end of the screwdriver and put the screwdriver down there and it'll stay on the screwdriver so you can thread it into the hole. So here we are. Lights are solid. I start the music playing. The music. I've got the idiot that owns this though arguing with me till I am blue in the face that the lights are not supposed to flash when it's playing. And he's arguing. I've got text message after text message after text message. His other amplifier, this is how it is. So he insists because he bought several. He's got one that they stay on all the time. This one here, one blinked and one didn't. And the other one, both of them blink. I'm trying to explain to this idiot that they're supposed to flash when there's signal. They're green when there's power. They flash when there's signal. And they turn red when they're into clipping. Which is exactly the same as my Crest operates. My Crest 900 operates exactly the same as this. Green light flashing when there's signal, and red when there's clipping, except for my Crest has a separate light for clipping, and it's marked. It's a red light that says clipping. This one here, they turn red. But I'm arguing with this guy, which means that I'm not going to get paid because he's gonna say that I don't know what I'm talking about, because that's basically what he's saying now. You can't fix stupid. Right in the manual it shows that they process signal and they turn red when there's clipping. The reason why one of them wasn't working was because that connector was falling apart. Now they've been hardwired, it's working as it should be, but the guy that owns it is insisting that that's wrong. What do you do? Anyway, this one's fixed. Here's his other one. Again, obviously there's been heat on that board. Not as bad as the other one. And the other channel over here, again, it's not as bad. I can go over the connections on here as well, but this one's not as bad as the other one. So I'm going to pull the boards out on this one as well and just re-solder the connections. I don't know that I'll have to hardwire this one though, because I don't think the plugs are falling apart on this one like they were on the other one. The other one, the plugs were actually coming right apart, right? So I'll just pop the boards out and redo those connections that got pretty warm. Actually, they are just as bad. They're crumbling as well, this connector. So I guess I'll be soldering this one on both sides, because you see these resistors are come loose. These are a dropper resistor, right? They're just taking the B plus and they're dropping it down through these 2.7K resistors, and then there's Zener diodes that are regulating for 15 volts for the reference circuit down here for the clipping and signal detection. Sig on PC. So we'll just do the same on this one. I'll hook these wires. Oh, this one actually came right off. The wire came right out of the connector on this one. So we'll just do the same on this one as the other one, and hardwire both of these ones in as well, and that way it'll prevent future problems on this amp. I would imagine this is a problem that all these units of this age. I mean, this thing probably has more connections in it that probably could be done, like pull the boards all out and go over the power resistors and stuff. And the emitter followers, there's a lot of stuff that can probably be done on these things, but the thing is that costs money, and the guy that owns this doesn't want to pay. You know, I'll be lucky if I can get $100 for both of these out of him. At that, he is going to squawk and complain. I should just tell him to take it to somewhere else and let them deal with him. So I'll redo the hot connections here on the resistors, Zener diodes, etc. It also must be a later unit, because the other amp, these were socketed, and these one here they're soldered in directly. These are awkward as hell to get to. This one's not quite as in bad a shape, but still, the plastic, as you can see, maybe you can't see because it's overexposed, but the plastic is all crumbling on these connectors. So because of that, they're going to go. Just increase the reliability of it tenfold by not having a plug. Plugs are the #1 cause of failures on everything. So we can eliminate a plug, we can eliminate a point of failure. And the kicker to this thing, this guy will probably be asking $5,000 or $6,000 for these amplifiers, and some idiot will pay that for it. But knowing this guy, he picked them up for about $100 a piece, because that's what he does. He goes to estates and stuff and picks stuff up dirt cheap, and then sells it to people that have got more money than brains, I think. You can see that the Zeners here have just about let go completely. And if they did, well, then the full rail voltage would go across this and fry the ICs. And then there'd be no light whatsoever. So that's why I'm doing this. And he's got some more, and I'll tell him to bring the other ones over, and I'll do the same on them just to fix it up so that it's not going to act up.
And then he'll be haggling me over the price. You know, he'll be like, well, you know what it was, so why are you charging me that for it? I want a discount. And that's when I tell him, well, maybe you should take it to Commercial Electronics and ask them for a discount. I'm sure that will go over well with them. This is the type of guy that you would say, resolder bad connections, $5. Knowing which connections to resolder, $100 or $150 or whatever. In fact, I might use that on him. Knowing which connection to fix. Knowing which plug to replace. Okay, that looks like the bad ones. We'll just reconnect the power here. So there we have both boards wired. So we got our negative and positive supply. The yellow one is the LED return. Green is ground, and the signal level is the violet wire on both of the boards. So now I can install this one, and this would prevent this from failing in the future. At least that's what the hope is to prevent future problems caused by bad connections on this board, which is problematic on these, as I've seen, because I got two of them in a row that have the same fault. Now this one's reconnected, and get sound. Pause the sound. I'm gonna shut off the power completely and unplug the inputs because I'm not using proper shielded cable. I'm just using jumpers to jumper over to the 1/4 inch plugs. Now there's no input whatsoever. Nothing, no flickers or anything. I'm just using like patch cords, right, to connect from my RCA cable to this. So there's always a little bit of noise. It gets induced just from it lying next to the AC power. So that would cause them to trigger slightly because there's a little bit of AC hum there. Perfect. That's what it's supposed to do. I don't know what the guy's going to argue with me. He's going to argue that it's not supposed to do this, that it's not supposed to flash. It's supposed to be green all the time. He's going to argue with me because I've been arguing with him about this for the past week. And he's going to bring another one over and try to prove his point. And I'll pull it apart and fix the connectors on it, and it'll work like this. And I'll say, okay, $100 please. Anyway, thanks for watching. We'll catch you in the next one. Bye.